In February 2001, Nicholas Carlyle came to Ball's Pyramid to confirm that the Lord Howe Island stick insect was extinct. It had last been seen in 1920. Dozens of expeditions since then had found nothing. Nicholas was there to close the case, but on the very first night he shone his flashlight under a bush and froze. 3 insects were sitting there that had no right to exist, each one the length of a human palm, black and glossy. 21 more were eventually found. That was the beginning of an operation to save the rarest insect on Earth. There are insects no one notices. Dryococelus australis, a stick insect up to 20 centimeters long and weighing up to 25 grams, the heaviest wingless stick insect in the world. Locals called it the land lobster for its size and black glossy shell resembling the chitin of crustaceans. Fishermen on Lord Howe Island actually threaded it onto hooks as bait. It was that common and available. This matters because of what it says about scale. An insect used as disposable fishing bait is an insect that exists in abundance. There were many of them, until June 1918. On the 15th of June, the steamship SS Macombo ran aground near the island. 9 days of repairs. In those 9 days, black rats from the hold came ashore. Lord Howe Island had known no land mammals in 6.5 million years. Its insects, birds, and plants had evolved in a world without threat from above. Within 2 years of the rats' arrival, the land lobster was gone from the island. By the 1960s, officially extinct. But there is one detail that doesn't fit this picture. In 1964 and 1969, climbers on Ball's Pyramid, 23 kilometers from Lord Howe, found freshly dead insects. Not fossils. Fresh. The rock is nearly inaccessible, the insect is nocturnal, and nobody went back to investigate. The rumors stayed rumors, until February 2001. To understand what Carlyle found under that bush, you first have to understand the insect itself. Most insects exist near one another, but not together. They don't recognize members of their own species outside of mating. Their contact is functional and brief. Dryococelus australis is built differently. A male and female stay together. They go out at night to a single bush and eat side by side. They hide in the same spot during the day, and when they sleep, the male places 3 of his hind legs over the female. Not beside her, over her. One scientist described it this way: 3 legs lying on the female like a hand. A constant connection you wouldn't expect from an animal with a brain the size of a dot. Then there is the body. A wingless stick insect is usually slow. Wings are speed, and without them the animal compensates with something else. The land lobster is wingless but can run. Massive, armored, and mobile. The rats weren't stopped by this, but it says something more important. This insect doesn't fit any familiar category. Then, reproduction. If a male exists, logic suggests he is needed. But a female land lobster can lay eggs without fertilization. From them hatch females, exact genetic copies of the mother. Parthenogenesis. This is most likely what kept the colony alive on the rock through all those decades when individuals could be counted on one hand. Yet males exist, and pairs are active. By Honen's observations, mating occurs up to 3 times a night. The species retained both options simultaneously and abandoned neither. And finally, something you see with your own eyes but don't immediately understand. The green insect that moves through leaves by day and the black nocturnal one that comes out to feed after sunset are the same species. Not 2 stages with a chrysalis between them, just a gradual shift. The color darkens, the rhythm inverts, the animal becomes something else without stopping. The same species lives 2 different lives in sequence: green and diurnal, black and nocturnal. The central question appeared in February 2001 when 5 people came ashore from a boat and began the climb up Ball's Pyramid. How this insect got there in the first place and how it survived for 80 years, nobody knows to this day. But that was the first moment anyone had a chance to even ask. The team consisted of scientists David Priddle and Nicholas Carlyle, Ranger Dean Hiscox, entomologist Stephen Fellenberg, and curator Margaret Humphrey. The stated goal was clear: prove the species is dead. Close the file. Carlyle would later explain, for years they had been fielding requests from people who wanted to go search for the land lobster. You look at the list, no entomologist, not one. The only way to stop it was to go themselves and confirm the extinction. During the day, they climbed to 150 meters. They found a few crickets, nothing else. On the descent, Carlyle shone his light under the single bush on the entire rock, Melaleuca hawaiiana, a tea tree endemic to Lord Howe. It grew from a crack in the basalt in the only patch of soil on all of Ball's Pyramid, and beneath it, large droppings, the kind only a very large insect leaves. Hiscox and Carlyle returned after sunset. At 70 meters in darkness with flashlights. Under the bush, 3 insects. 2 adult females and 1 nymph. They were eating leaves. They showed no reaction to the humans. On that rock, they had never had reason to develop a response to threat. The first count over the following days would show the entire population of the species, approximately 24 individuals. The entire range, 1 bush and a few square meters around it. On a vertical rock face in the middle of the ocean. All 3 individuals found were female. Without males, parthenogenesis could sustain the colony, but without genetic diversity, not indefinitely. In 2003, after 2 years of bureaucratic negotiations over whether individuals could be removed from the species' only known habitat at all, permission came through to take 4. The team returned to the rock on the night of February 14th. On arrival, they found signs of a rockfall. A few seconds of panic, then they found the insects alive in another part of the bush. 2 were taken to Melbourne Zoo. Patrick Honan, curator of invertebrates, named them Adam and Eve. The second pair is talked about less. Over 2 more years of observation on the rock, males were found. The population proved to be mixed. In 2003, 2 complete pairs were collected. One was transferred to private entomologist Stephen Fellenberg in Sydney, the same person who had climbed the rock in 2001. At first, everything went well. The female laid 21 eggs. Then, on day 29, the male died. She followed the next day. 2 insects on whom half the program's hopes rested were gone within a day. The cause, unknown. This species had never been kept in captivity. No protocol existed. 8 nymphs hatched from the 21 eggs. The Sydney colony persisted for several more generations, and then it too collapsed. This is important to understand when reading the program's numbers. Everything could have ended differently. The species had never been held in captivity. Everything had to be learned through observation, and one of the first discoveries concerned the male. The male land lobster is about a quarter smaller than the female, but his hind legs are disproportionately massive, with 2 large spines on the femurs. Honan documented the function. At night, when the pair feeds and moves, these legs are tools. When they retreat and sleep together during the day, those same 3 legs are what the male places over the female. 1 organ, the spine as a weapon, and the spine as an embrace. The female begins laying eggs 2 weeks after her final molt, a precise biological clock built into the insect's body. Each egg is the size of a pea. Creamy white, with a raised mesh pattern on the surface. Under a loop, it resembles a miniature barrel. The female buries eggs in the soil with her abdomen, in batches of 9 or 10, with a week's pause between clutches. Then months of silence. Incubation lasts 6 to 9 months, nearly a year of waiting over a container in which nothing appears to be happening. When the nymph finally emerges, it is already 3 times the size of the egg it just left. It had been folded inside all that time. Rohan Cleve, the breeding program manager at Melbourne Zoo, described it precisely, like a paperclip in a capsule. 5 molts separate that green paperclip from the black nocturnal insect. 7 months, and the species repeats itself again. Then Eve became seriously ill. Honan had no protocol. He worked every night for a month. This insect is nocturnal, and he adjusted his schedule to match. Nothing helped. In the end, on instinct, he mixed calcium and nectar. Drop by drop, he fed it into her mouth as she lay curled in his palm. Within a few hours, she was up and moving. Eve laid 248 eggs during her life in captivity. The first 30 were fertilized. On September 7, 2003, a nymph hatched from one of them. Bright green, active by day. Australia chose that date for Endangered Species Day in memory of the death of the last Tasmanian tiger in 1936. The rarest insect on the planet was born on the anniversary of an extinction. That day became the starting point. From Eve's 30 eggs, Melbourne Zoo rebuilt a population that by 2021 had exceeded 19,000 individuals across 16 generations. That number is difficult to process alongside where things began. One bush, 24 individuals, not a single male among the first 3 found. But there is a detail the numbers don't show. Nearly the entire captive population descends from a single female. Eve laid 30 fertilized eggs. Adam was the only male at the program's start. This isn't simply few individuals. It is a genetic bottleneck. When thousands of insects are descended from one pair, any inherited weakness passes to all of them equally. By 2008, the zoo already held over 700 adults and 11,000 eggs. That year, Jane Goodall came to see the program. In August 2012, David Attenborough came, not to film, just to look. Rohan Cleve, who walked in between the incubators, said afterwards simply, "Exactly like on screen." That same year, a photograph, a green nymph unfurling from its egg in the first seconds after hatching, placed in the top 10 at the Eureka Prize for Science Photography. The image shows the insect literally straightening. A moment ago, folded inside a capsule the size of a pencil eraser, and now alive, green, 3 times larger than its egg. In 2017, one more female was collected from Ball's pyramid to broaden the genetic base. At that point, 16 individuals remained in the wild. That same year, a team led by Alexander Mikheyev compared the DNA of insects from Ball's pyramid with museum specimens collected on Lord Howe before the extinction. The divergence, less than 1%. The same animal. But they also found something else. The land lobster's genome is larger than the human genome, over 4 billion base pairs. And most likely hexaploid, meaning 6 copies of each chromosome instead of 2. An insect considered dead for 80 years carries one of the largest genomic libraries of any known insect. Why and what it means are unknown. Reserve colonies have been established in Bristol, San Diego, and Toronto. Eggs from Melbourne are counted in the tens of thousands. Parallel work was underway on the island itself. In 2019, the eradication of 150,000 rats and 210,000 mice on Lord Howe, the largest such operation ever conducted on an inhabited island. In 2021, 2 surviving rats were found, a pregnant female and a male. The count reset. The operation was repeated. In August 2023, 2 years of monitoring confirmed. The island is clear. The island responded faster than expected. The endemic woodin had fewer than 250 individuals before the 2019 operation. By March 2025, there were over 1,600, more than 6-fold growth in 6 years. But the most unexpected finding wasn't that. In 2022, 2 scientists turned over a rock on a monitoring plot and found a living endemic cockroach, Panethia lata, not seen on Lord Howe for more than 80 years. It had survived an entire century by literally hiding. The land lobster on the rock had not been the only one to outlast the catastrophe. It was simply the one found first. Beetles, weevils, forest cockroaches not recorded in the leaf litter for decades began appearing in traps almost immediately after the rats disappeared. The island didn't simply recover, it began returning things researchers hadn't even known were still alive. But the insect itself is not yet on the island. There is one thing that remains unresolved. The land lobster is not a solitary animal that can be bred in isolation and released. It forms pairs. It has behavioral bonds, a daily rhythm, and attachment to specific plants. Decades in captivity, under controlled conditions, with particular plants and temperatures, that is not the same as a wild island. There is also a purely microbiological problem that doesn't appear in press releases. Recent studies examined the gastrointestinal tracts of insects from zoos and found strains of entomopathogenic bacteria not present on Ball's pyramid. Decades in captivity, different plants, different microclimate, and the microbiome has changed. Releasing these insects into the wild population means introducing something to the rock that was never there. A newcomer again. An island without immunity again. Only this time not a rat, a bacterium. So simply breeding and releasing is not possible. Insects from the zoos are now being gradually transitioned to plants characteristic of Lord Howe. Each generation is tested against the local climate without controlled humidity and temperature. Each generation is one more step toward the state in which they can be returned without risking the destruction of what survived on the rock. The first trial release is planned not on the main island, but on Blackburn Island, a tiny patch of land in the lagoon, 800 meters offshore. If it works there, the next step is the forest. But there is a question nobody can yet answer definitively. The land lobster was the primary processor of plant matter in the Lord Howe forest. Carlyle calls it an ecosystem engineer. 5 bird species that regulated its numbers are gone. The island the insect will return to is no longer the island it disappeared from. Without predator pressure, the population could grow uncontrolled. The rats, in destroying the lobster, also destroyed the birds that kept the lobster in check. Nobody yet knows what balance looks like without either. And the wild population on Ball's Pyramid, the same one that survived everything, is still there. By various estimates, between 9 and 40 individuals live on that same patch of rock. Today, in zoos across 6 countries, live the descendants of 3 insects Carlyle found under a bush in February 2001. Melbourne, Bristol, San Diego, Toronto, Lord Howe, and from February 2026, Prague, where juveniles were bred for the first time. The 6th zoo in the world. The 16th generation from Eve. The island is clear of rats for the first time in 105 years. Trial enclosures on Lord Howe are already being built. The first release, possibly on Blackburn Island in the lagoon, 800 meters offshore, has not yet happened, but a date is possible for the first time in a century. For now, though, not a single individual on the main island. Not one in the wild, except the rock. On Ball's Pyramid, the same population still lives. 20 to 40 individuals, depending on the year of the count, on that same patch, under that same bush. And every night, the same thing happens that has happened for the last 100 years. A male and female emerge from shelter together. They eat side by side. The male, a quarter smaller, places 3 legs over the female. At dawn, they hide. They wait for dark. They don't know they were searched for. They don't know they are counted in thousands in incubators across 3 continents. They don't know that the island from which they were erased in 2 years is finally ready to receive them. They simply do what they have always done. At night, they emerge. By day, they hide, and they wait.